Graphing linear equations. So, to review things that you learned in Algebra 2 and possibly also geometry, the standard form of a line is ax plus by equals c. This is useful when we want to graph lines in terms of the x and y intercepts. So the x-intercept, where the line intersects the x-axis, means that y equals 0. The x-intercept is where y equals 0. So to graph the x-intercept, I would plug 0 in for y into the equation. And so I would get 3x equals 2, and that means that x is 2/3. So I would graph a point on the x-axis at 2/3. And then the y-intercept is going to be where x equals 0. So plug that into the equation. And so we would get negative y equals 2, which means that the y-intercept equals negative 2. And so we would plot a point at negative 2. And then we should be able to draw a line that goes between these 2 points and is approximately straight. And looks something like that. That would be approximately the graph of the line 3x minus y equals 2. The slope m of the line x1, y1, and x2, y2 is given by the equation y2 minus y1 over x2 minus x1, assuming that x1 and x2 are not equal to each other, because in that case you have a vertical line which has no slope. The slope is undefined. It doesn't matter which point you pick to be x1, y1 and which you pick to be x2, y2, as long as you keep your 1's together and your 2's together. American farmers produce enough food and fiber to meet the needs of our nation and to export huge quantities to countries around the world. In addition to raising grain, cotton, and other fibers, fruits, or vegetables, farmers also work on dairy farms, poultry farms, horticulture specialty farms that grow ornamental plants and nursery products, and aquaculture farms that raise fish and shellfish. In 1900, the percent of American workers who were farmers was 37.5%. In 1994, that percentage has dropped to just 2.5%. What is the average rate of decline in the percent of American workers who were farmers? So, in the year 1900, the percentage was 37.5%. In the year 1994, the percentage was 2.5%. So we can treat these as ordered pairs, and so our average rate of decline is going to be, and here it doesn't really matter. So if I say this is x1, y1, and this is x2, y2, then 2.5 minus 37.5 over 1994 minus 1900 is going to be negative 35 over 94, which is about a slope of negative 0.37. From a graph, we can easily read off the slope and the y-intercept. The slope of the line is the rise over the run. So pick 2 points on the line. Points that go through integers are often helpful. So any 2 points, though, will work. So from here, the rise is 2 and the run is 3. So the slope of this line is 2/3. The y-intercept is where it crosses the x-axis, or where it crosses the y-axis, which at this case, halfway between -2 and -4 is -3. Notice here, so the scale of this, each block is not 1, each block is 1/2, but that then makes this one rise over run of 1 over 1.5, which is the same as 2 over 3. So as long as your scale is the same in both directions, you can, in fact, actually just count the blocks, even if each block is not equal to 1. So we get the slope of the line and the y-intercept, which brings us to the form of a line that you are probably most familiar with, which is slope-intercept form, y equals mx plus b, where m is your slope and b is your y-intercept. So, using this example, the equation of this line would be y equals 2/3 x minus 3. When you are graphing a line in slope-intercept form, you want to graph the intercept first. So this is going to be an intercept of -2. And then your slope is just your rise over run. So a slope of 3/4 means rise 3 and run 4. And we can also go down 3 and to the left 4 as well. It helps sometimes to get a few different points. And then we draw a line through it. Here, this equation is not in slope-intercept form, but we can put it in slope-intercept form by solving for y. So, in this case, this is pretty easy to solve for y. We just got to move the 3x over. So we would get y equals -3x plus 5. And so our intercept is at 5. And we have a slope of -3 over 1. So down 3 and 1 to the right. And we can do that several times and get a line. Several points that we can make into a line. The third form of the line is the point-slope form, and this is most helpful when you have a point and when you have the slope, or when you are trying to find the equation of a line that goes through 2 points. You can rearrange this to put it in slope-intercept form, but this can be kind of a handy shortcut for those problems where you have 2 points and you have to find a line that goes through them. So y minus y1 equals m times x minus x1, where m, again, is your slope, and x1, y1 is a point on the line. So write an equation in point-slope form of a slope that line with a slope of 4 that passes through 3, 2. Right, so y minus y1 equals m x minus x1. So 4 is your m, 3 is your x1, and 2 is your y1. And so this is going to be y minus 2 equals 4x minus 3. If we wanted to put this in slope-intercept form, then all we would have to do would be to distribute the 4, and then add 2 to both sides. So this would be in point-slope form, and this would be the equivalent in slope-intercept form. For a line that passes through 5, 2, and 7, 9, we have 2 points, but what we don't have is the slope. So we're going to have to find the slope. All right, y2 minus y1 over x2 minus x1, which is going to be, say, 9 minus 2 over 7 minus 5, which is 7 over 2. So then in point-slope form, y minus, you can pick either one of these points. It does not matter. I'm going to go with the first one, just because. And our slope was 7/2, and this is x minus 5. There you go. Point-slope form. Again, we could put it in slope-intercept form if we wanted to, but the question doesn't say to do that, so let's not. Values of x for which the function is equal to 0 are called zeros of the functions. If the slope of a line equals 0, the line is a horizontal line. If the slope of a line is undefined, the line is a vertical line. So the zeros of the function, f of x equals 5x plus 4. So if we were to graph this, we would graph the intercept first at 4. And then we would have a slope of 5, rise 5, and run 1. In this case, I'm going to go down and to the left just because I don't really have room to go the other way. And so it looks like, I don't know what happened there. It looks like we have an intercept here at what looks to be negative 4/5. We can also solve for this algebraically by setting the equation equal to 0. So the 0 of the function is where f of x equals 0, so plug in 0 for f of x and solve for x. And we do indeed get that x equals negative 4/5. Same thing here. If we have an intercept of 3 and a slope of negative 2, the 0 of the function appears to be 1.5, or 3/2. We can also find it by plugging in 0 for y and solving for x. And it is indeed equal to 3/2. And as a refresher, a line of y equals 1 is going to be a line where all of the y coordinates are equal to 1. So for any possible x, y is always 1, and that gives us a horizontal line. A line of x equal negative 4 is going to be one where all of the x coordinates are equal to negative 4, and that's going to be a vertical line. Horizontal line has a slope of 0. Vertical line has an undefined slope. And that's it for this section. Tune in next time for Parallel and Perpendicular Lines, which I'm sure you're super excited about.